So find the area of the inner loop of the limacon. The formula is given, 3 cosine theta minus 2. Limacon has an inner loop. It's usually something like this. The inner loop sometimes is huge, or sometimes it's tiny, or sometimes it doesn't exist. Then it's just a heart. Cardioid, they call it cardioid. Cardio. Then they gave me one of the angles, the positive angle. So they never gave me the negative one. Well, just put it, make it negative. It's symmetrical. So instead of doing the whole loop, you're supposed to do the whole loop around to make it angle with the positive, which will be 2 pi minus theta 1. Or use a symmetry. It's going to be minus theta 1. Again, that was given. Minus theta 1 will be minus arc cosine of 2/3, which is approximately minus 0.841. So luckily that was given. It's actually a blessing if the angles are given, because finding them, it's a hassle. Working with inverse functions is a pain, and if they don't give you unique answers, you have to be good to know what's going on. When you know the angles, you just need to know the formula and you're done. Yes?
For the bottom one, is that a negative theta one?
Yeah, so I made the one we had to be negative. Let me make it red. Here it is. Let's see, so this was given. Then, and then the one they gave me, it's going to be upper bound, so it's going to be beta. Beta is given. Then alpha will be minus theta 1. Does it make sense? And the integral will be from alpha to beta, from minus to plus. From minus to plus. Because the shape, let me zoom in, the shape of this inner loop, which we're looking, the area of the shape, started from minus to plus. It's always positive direction unless they say otherwise, and that is counterclockwise. So it went from minus angle to plus angle. That's why it goes from minus theta 1 to plus theta 1. Solution. Let's go back and check carefully what they're asking. We know 2 formulas in polar. Integral from alpha to beta, original square plus derivative squared, and 1/2 integral from alpha to beta, r squared. You need to write down both, maybe, so your brain remember both, and then choose the correct one. With 1/1/2 is the area. So that's the one we need. Area is 1/2 integral from alpha to beta, r squared d theta. So 1/2 comes from the area of the sector. We're using sectors to approximate the areas in polar. R d theta, r squared d theta. This is the formula we need. And alpha and beta, so beta was given. That means we are very happy about this. 1/2 beta was given right away. That is arc cosine of 2/3. And using the symmetry of the picture, which was also given, we know that alpha will be minus arc cosine of 2/3. Does it make sense? I'm glad someone said yes. That's nice. R squared, find your R. Here it is. R is 3 cosine theta minus 1. Squaring that. 3 cosine theta minus 2. Sorry, I heard you saying that. And now we're squaring it. Square is a part of the formula. D theta. So 1/2 r squared d theta. This is going to be on a test as an integral. Why? Because it reviews how to integrate cosine square. That is important. And it also have use substitution again. Use substitution. So let's do it. 1/2. Since I don't want to write down all the time those alpha and beta, can we just write down alpha and beta for now? Too annoying. Too much writing. Alpha and beta, and we know them. So just keep in mind, we know them. Or you can do minus beta and beta, for example. 1/2. 2 cannot just come in. Remember, if you just put 2 on each part, some panda cries somewhere. You cannot do that. You have to use formula square of difference. 9 cosine squared minus double product. 2 times 2 is 4. 4 times 3 cosine theta plus square of the second one, which is 4. Approach me after class if you want to ask what we just did. But that's called square of the difference formula. Now you need to integrate all of those pieces. The first one is the hardest one. Others are fine. Why did I say it was chain rule? There's no chain rule here. The previous question had chain rule. So how do we integrate 9 cosine squared? 9 times what? How do we integrate, let me put it in pink, cosine squared? Integral of cosine squared is cosine cube over 3. No, who said yes? No, that's not correct. Double angle formula, right? Half angle formula, double angle formula, those can be your best friends. So cosine squared is, I remember it's 1/2, 1 plus or minus, and it's always cosine double input. Now you just need to remember if it's plus or minus, plus, because cosine likes cosine. It's nice. Minus 12 cosine theta plus 4. We are almost done. That's all inside of the integral. Oh, there is chain rule because of the 2 theta. I remember why I said that. Now, start integrating 1/2 and then maybe brackets. 9 over 2. So 9 over 2 have to be distributed carefully. 9 over 2 times 1. Integrating that gives you 9 over 2 theta. You could actually simplify 9 over 2 and 4, but I did not do that. Then 9 over 2 times cosine. Integrating that. Integral of cosine is what?
Negative sign.
Negative sign. Yes or no? You should check the derivative. Derivative of minus sine. Does it give you cosine? So I only remember derivatives. And that's I purposely refused to memorize integration for sine and cosine. I remember derivative of sine is plus cosine. So that should be plus. Thus, I highly recommend not to memorize both. Memorize just one of these. Thank you. What else? Divided by leading coefficient. That is a shortcut of U sub. Review U sub. I like shortcuts, so this time I will do shortcut. And I also missed what? 9 over 2. So put it in front. 9 over 2 should be distributed. I don't know why it's sinking down. Let's go up. Nice. Minus integral of cosine, we just repeated, sine theta plus 4 theta. Make sure your theta is not like O or 0 or else it's going to be 40. So that's actually pretty important. Remember, theta is actually an O. It's a letter. So it has to be a little bit bigger than 0. Equals bar from alpha to beta. And now this is like annoying part starts when you actually have to plug alpha and beta. And alpha is minus arc cosine of 2/3. And beta is plus arc cosine of 2/3. Someone says I will make it wrong. You don't have to simplify it, but if you do, actually it gets better. Does it? Well, at least you can collect these together, and that's it. The sign of double angle formula actually has some solution to make it better as well. But you see, mine is already better than I've seen someone else in the office hours. No, any matching of names are pure coincidence. So, it gives you the answer. Approximately, I just like very smart, and I know that it's approximately 0.441. And that is the answer. Units what? Squared. Remember, it's area. It's better be positive. Area and arc lengths, both better be positive. If you give me negative area or arc lengths, you messed up, and you should know it, yes.
On the test, we have to write units or units squared.
No, I don't mind. I'm specifically as instructor, I don't care about units. Some instructors do, so it's nice that you're asking. Yes. I think in other physics classes, they torture you with units all the time, so it's fine.